This is MSJ Chem. In this video, I'll be looking at the solubility and bioavailability of aspirin. Aspirin is only slightly soluble in water. The solubility of aspirin can be increased by reacting with aqueous sodium chloride, forming an ionic salt. So if we look at the structure of aspirin on the left, we can see that it has a phenyl group, a carboxyl group, and an ester group. Although it has a polar carboxyl group, the solubility is limited due to the presence of the non-polar phenyl group. So to increase the solubility of aspirin, we react it with aqueous sodium hydroxide to produce sodium acetyl salicylate. The product is known as soluble aspirin due to its increased solubility in aqueous solutions. When water is added to the soluble aspirin, it dissociates to form sodium ions and acetyl salicylate ions. So here we can see the soluble aspirin dissociates to form the acetyl salicylate ion and the sodium ion. Ionic salts of aspirin are more soluble in water since they form stronger ion-dipole interactions with water molecules. Next we look at the bioavailability of aspirin. Converting aspirin to an ionic salt increases its solubility but does not increase its bioavailability. This is because the acetyl salicylate ion is converted back to the unionized form in the acidic environment of the stomach. So here we can see the acetyl salicylate ion reacting with a hydrogen ion to form the unionized form of aspirin. So converting to the ionic salt increases the solubility but does not increase the bioavailability of aspirin. One method of increasing the bioavailability is by administering the drug intravenously. As we saw in a previous video, the bioavailability of an intravenous injection is 100%.